Okay, here's justify number 10. It's asking, what is the greatest prime factor of this value, 9 to the 18th minus 3 to the 32nd? And I did give you a hint. I use a common base. Using a common base is very useful. So if we take a look at a simpler example, like 27, this example right here, and we factor it using a factor tree, we can see that we'll end up getting 3 times 3 times 3, which is equal to 27. But even more importantly, you can get a prime factorization, a product where all the numbers, all the factors are prime numbers. Okay, and that's great because that's what it's asking you for. What's the greatest prime factor? And in this case, it would be 3 because there's no other factor greater than 3. So we are looking at this value here. For this value, right, this difference, if we can get our value written as a product, then we can maybe see what is the greatest, the greatest prime factor. What is the greatest prime factor? So the student here at the bottom, you would make 9 to the 18 into a base of 3. So then it would be 3 squared raised to the 18th, right? Because we're just replacing 9 for 3 squared. Then that's what you would get for 9 to the 18th. And then this second term in your difference is already in base 3. So far you have this difference now representing the difference. Notice it's not a product yet, but it's nice because you do have a common base. So then you could actually factor this, okay? Turn this difference into a product by taking the greatest common factor between these two. And that would be 3 raised to the 32nd, and then times the factor 3 to the 4th minus 1. And you can always double back and see that it is in fact equal to this difference. So now what happens is you have this product. And this product, you can see that this is a product of multiple factors of 3 all the way down to 32, right? So this right here is just repeated factors of 3. But this right here is a little bit different, okay? This right here, 3 to the 4th minus 1, can actually be represented as 80 because 3 to the 4th minus 1 is 80. And if you do a factor tree on that, which I did here kind of going left to right, 80, okay, that's 81 minus 1, which is 3 to the 4th minus 1. 80 is equal to 8 times 10, and then 10 can be broken down here, 8 can be broken down here. You get a multiple amount of factors of 4. Oh, sorry, factors of 2. That's smaller than 3. We're looking for the greatest prime factor. And then you have this 5 here. This 5 is larger than 3, and so that's where the student's getting their answer. Okay, so when we factor 80, we get 2 to the 4th times 5, so 5 is the answer. 5 is the greatest prime factor of that difference, the original difference, which was right here. Okay, so we manipulated that, turn it into a product so that we could figure out what was that greatest prime factor. And that's justify number 10.